first your the instructor says that you're solving differential equations. That's actually an entire course. You're doing like the most basic ones that could be possible. Another thing here is you're solving initial value problems. And you actually can do these together. And that's what I was going to do today. I was going to give you a differential equation, which you're going to see pretty quickly you solve through integration always. And then initial value problems is just an additional step each time. So I could give you a problem that looks like this: dy dx equals x squared minus x, and ask you to solve first ask you to solve the differential equation. So you do that. There's depending on your instructor, you actually are supposed to move this dx over here, and then this dy stays in left. So it's integral dy equals integral x squared minus x dx. I don't know if you saw that in class, but that is kind of the correct step. It's not necessary, but it's like that's why this works. The left side becomes y, and the right side you integrate as you did before.
So like the antiderivative?
Exactly.
Okay, so x cubed over 3 minus
Yes.
x squared over 2?
1/3, yeah, x cubed minus 1/2 x squared. And I'm really frustrated because I can't seem to get this thing to move down. So let me do it another way. You need to just get some space into this. So let me see here if we can get this. There we go. Okay. Yeah. So does that make sense?
Yeah.
How to do that? Okay. Now, additional part. There's this plus c. There's always a plus c when you integrate. Now, again, I don't know how much the instructor gave you, but if I actually, the correct line here is y plus c1 equals 1/3 x cubed minus 1/2 x squared plus c2. And then you can subtract c1 from both sides. So you get the same thing. You get y equals 1/3 x cubed minus 1/2 x squared plus c2 minus c1. And then you can say, oh, well, c2 minus c1 is really c. And that's why it ends up being just plus c when you're all done here. So you don't have to do any of this on the right, although this is like the completely correct, full version, everything. Right. You just need to know there's a constant of integration. Okay. And that's where this initial value problem comes in. Or you'll see, sorry, let me write that correctly. Initial value problem, or sometimes they just say IVP for that. And that's where they tell you, okay, y of 0 equals 1. That's x, that's y. And you can substitute these values and see. So 1 equals 1/3 0 cubed minus 1/2 0 squared plus c. Okay. And you get 1 equals c. So then you take that value and you put it back into, this line up here.
Right. Okay.
So your final answer is y equals 1/3 x cubed minus 1/2 x squared plus 1. And that's your final answer.
Okay.
This is not the same as like when you integrate from 0 to 1, although it could in some ways appear to be the same as that. It is not the same though.
Okay.
So here you got a function and here you got a number, if you recall that.
Right. Okay.
All right. So let me ask you to do one on your own here, just a polynomial here. Yeah, so let's go with this. Dy dx equals x to the 4th minus x to the minus 2. And we'll make it slightly harder. We'll say y of 1 equals 1. Okay. So the first step is to you can literally just write y equals the integral x to the 4th minus x to the minus 2 dx, or you can just integrate it. Like you don't even have to show this, but you can if you think that would be helpful.
So then it's 5 x to the negative 1. So it's x to the fifth over 5
right?
minus x to the negative 1 over 1, negative 1.
-1 plus c.
Yeah, plus c.
And it's worth simplifying here. So plus 1 over x plus c. And then again, you have this initial value here.
So then just 1 equals,
1/5 times 1 to the 5th plus 1 over 1 plus c.
wait, but why are you putting 1 in for x?
This is x,
Oh,
and this
wait.
is y. So I don't have to always give it to you as x being
Oh.
0 or y being 1 or anything like that. It's whatever it is.
Where 1 equals 1/5 plus 1 plus c.
Right.
So then minus 1, c equals 1/5.
So yeah, it's actually -1/5 because you got to move this over.
Yes. Okay. So
Okay.
then it's
So you go back to
equals
that.
1/5 x to the 5th plus 1 over x plus or minus 1/5.
Yes, and this is your final answer that your instructor is looking for.
Okay.
Okay, so let's vary the notation a little bit so you can see what you might see. I could say f prime of x equals e to the x, and I could tell you that f of natural log of 2 equals 4 for your initial condition.
All right. So you just integrate e to the x, right?
Yeah, it's the integral e to the x dx.
E to the x. Well, isn't e just always itself?
That's right. Now, have I sent you the table of integrals that are worth knowing here?
I don't think so. Maybe.
Maybe. Let me see if I can find it real quick. There's tons of these out there, kind of like table of derivatives, table of integrals. There's some that you need to know, and this is one of them. So
is it just e to the x in this case?
it is. It is.
Okay.
And these are on page 2. So yeah, but it's e to the x plus c.
Okay. Sorry, I was just opening that.
Now you got to substitute. You got to find c. You got to substitute in your initial condition here.
So 4 equals L e to the ln 2 plus c. The e and the ln cancel out, so then it's 4 equals 2 plus c.
Yes.
2 equals c equals 2. So then it's just e to the x plus 2 is your final.
Yes. Okay, now let's just say I wanted you to find what's some other notation they could use. They could say y prime equals e to the x plus 2. Oops, plus 2. Okay, and I could tell you that y of 0 equals 1. Okay, so this time y prime, I've given you a few variations. These are all the same.
Okay.
Whether you see one or the other.
So then it's just e to the x plus 2x.
Yes, becomes e to the x plus 2x plus c.
Yes.
Very important.
So then it's 1 equals e to the 0 plus 2 times 0 plus c. And then e to the 0 is 1 plus 0, so nothing. C equals 0. So then it's e to the x plus 2 plus 0. Do you need to write the plus 0?
No, you just write y equals e to the x plus 2x. So sometimes the constant is 0.
Okay.
All right. Yeah, so I guess we'll do a couple more here. And that's really it. They just get more complicated until you know more rules of integration.
Okay.
But okay. So it could be dy dt. That's another thing. We could change the variable. So it could be secant squared t minus 3e to the t plus t over here on the right. So y is now a function of t when you're done integrating all of this.
Okay, so.
This is where that table might help. That's definitely one you got to remember.
Yeah, the secants and the cosines and all those always
Yes.
throw me off. So secant, okay.
You've got that link out.
Yes, I'm looking at it right now. Okay, so
it's in that trig function section, third one on the right.
is it secant tangent? No, we're just doing secant.
Just secant antiderivatives tangent.
Wait, but isn't it secant squared is tangent?
Right, and that's what we're integrating here, secant squared. Maybe
Oh, I see.
maybe it's not clear, but yeah, that's so the variable really doesn't matter, but you gotta use the right one. Like,
and then it's minus 3. That's complicated. Is it just 3e to the t? Yeah.
yes.
Okay.
Plus 1/2 t squared plus c.
Okay, and then it's.
So now I can give you an initial condition. I'll be kind on this one. We'll say y to the 0 equals 3. We'll do some trig ones next.
Tangent of 0 minus 3e to the 0 is 1/2 0 squared. So tangent of 0 is sine over cosine. So
That's the
-1. No.
So it's tangent is y over x. So this is 0 over 1 here from the unit circle.
Oh, so 0.
Yep.
Minus 3 times e to the 0. Is that just 1?
Yes.
Okay. Plus 1/2 of 0, so nothing plus c. And then, so that's plus 3, c equals 6.
Yes.
And then you just put that up top. So it's tangent t minus 3e t plus 1/2 t squared plus 6.
Yes. Okay, so the two trig functions that you really got to know really well, and not confuse them, which could be note cards, could be just staring at them, and they're not to be confused with their derivatives either. Like the integral of cosine is sine, the derivative of sine is cosine, the integral of sine is minus cosine, the derivative of minus cosine is sine. So you gotta be able to go back and forth between them. And like that's usually something that, so I'll leave this up, but I'll like the problem will look like this. Say y prime equals cosine theta, and then we would say that y of pi over 3 equals 1. That's your initial condition for this. So on the left here, you would write the antiderivative of this, which is sine, but it's theta this time, plus c.
Okay.
And they have 1 equals sine pi over 3 plus c. So now you got to remember your unit circle even better this time. So sine pi over 3 is there. So that's 1/2 comma square root of 3 over 2.
Okay, so
This is where it's like, well, what do I do? Well, you just subtract square root of 3 over 2 from both sides.
1 minus square root of 3 over 2 though, what is that?
It's just that. And that's the point of this problem is you
Oh,
might
I
get
see.
something, you might get something like that. Like it's okay that the answer is sine theta plus
Okay.
1 minus square root of 3 over 2. Like it's totally okay. And you
Okay.
should be comfortable with that. All right, so now let's do another one here. Let's do the integral. Let's say f prime of t equals what did I do? I did this one. So we'll do sine t. And then I'll tell you that f of pi over 4 equals square root of 2.
Okay, so f of t equals, so it's the antiderivative sign.
Yes. So it's that one on the right I was showing you on this. If you scroll up here, we're now doing this one. So you got to be very comfortable, whichever one you're given.
So negative cosine t.
T plus c.
Okay. So then root 2 equals negative cosine pi over 4 plus c. So pi over 4, that's the root 2 over 2, right?
Yep.
But it's negative. Do I just put negative root 2 over 2?
You're going to add root 2 over 2 to both sides? Yeah, it is negative because of that in front.
Okay. So then it's just c equals root 2 plus root 2, plus root 2 over 2.
So this one's over 1. So you could say 2 and then 2. And then that gives you 3 root 2s over 2.
2. Oh, multiply by 2 on the top and bottom.
Yes.
So then it's 3. Okay.
And then that goes back there. Oops,
Yeah,
previous line right
Okay.
there. So you got f of t equals minus cosine of t plus 3 square root of 2 over 2.
Okay.
Okay, so we can do a lot of these, but I was going to move on to an example that they often cover in this class at some point, unless you would like more of those stock examples.
No, I think we can. Those make sense.
There is, like your instructor uses the fundamental theorem of calculus to solve initial value problems. It looks like maybe doing them on the calculator. I don't know. And then we got to do some slope fields stuff.
Yeah, the slope fields confuse me.
Yeah. Okay. So this is the example. So in physics, the gravity due to acceleration is minus 9.8 meters per second squared. So if you were to, your velocity is really it's a differential equation. It's dv dt equals minus 9.8. Okay. And if you were shown this, you could actually solve it. So v is equal to the integral minus 9.8 dt. So this is minus 9.8 t plus c.
Okay.
And then let's just say the thing has an initial velocity of, I don't know, 10 meters per second. Okay, that is used in this equation. So 10 equals minus 9.8 times 0 plus 10. I'm sorry, plus c. Okay, and so your c ends up being 10, and you put it back into this example here. So v of t equals minus 9.8 t plus 10, like that. But this is also a differential equation. The derivative here, the derivative of position, is this minus 9.8 t plus 10. So when you integrate both sides, your position function becomes minus 4.9 t squared plus 10t plus c. And let's just say I tell you that your initial position is 5 meters away. So that means 5 equals minus 4.9, 0 squared plus 10 times 0 plus c. C ends up equaling 5. And you plug that back in to this equation here. And what we have effectively done is used initial conditions twice. So you can actually keep solving these initial value problems as many times as they ask. Okay, so let me give you an example, something more like you would see in your classroom.
Okay.
So this is something you might see. X d squared x over dx squared over dt squared. Sorry, let me get that right. Equals t. And x, oops, I keep doing the wrong, x prime of 0 equals 1, and x of 0 equals 2. Okay, so you might think, well, how do I use that? Well, first thing you have to do is take an antiderivative of this. Okay, so what is the antiderivative of t?
T squared over 2.
1/2 t squared over 2 plus c. Now this is the second derivative. So when you integrate it, you get back to the first derivative.
Okay.
Right. If you were to take a first derivative and get the second derivative, you go that way. So it must be the other way. So notice this initial condition on the right, this one applies. Because this is x prime right here. So you're solving this equation, but you're using this initial condition. So 1 equals 1/2 0 squared plus c.
Then it's c equals
1. So that goes back here. So you have dx dt
1/2 t squared plus 1.
All right. And then you can integrate this. You can find the antiderivative of this.
Oh, wow. Okay.
So it's x, right? It's x of t. And then,
so wait, 1/2 t squared. What did I say? It was t squared over 2, right?
Right, but that, so you're gonna go up one more power.
Cubed plus over 3.
Over 3, and then you got this 1/2. What about this plus 1? What does it become?
Oh, you keep the 1/2. Oh.
Yes.
Plus 1x, just x.
T because our variable's t, plus c.
Yep.
And then I told you that x of 0 equals 2.
So 2 equals 1/2 0 cubed over 3 plus 0 plus c. So then 2 equals c.
Yes. And notice we keep using c, but that's okay. Like we use c up here. You can always use c, even if you're doing it twice.
So then it's 1/2. Wait, yeah, 1/2 t cubed over 3 plus t plus 2.
Yes.
But you just combine the denominators. Okay.
Yes. And you should be expected to do that. Like, don't think, oh, Matthew's giving me this weird example. Like, it's totally reasonable for your instructor to ask you to do that.
Okay.
On there. Okay. So let's move to slope fields.
Okay.
So let me give you a differential equation that's really simple. Let's say dy dx equals 1 or 0. This is ridiculous, but let's do this. Okay, so this means in words, the slope at every point is 0.
Okay.
Does that compute? Like, does that make sense that is what it is?
Yeah.
Like you okay. All right. Okay. Because that's important here. So we're gonna go to this Desmos slope fields. It used to be before this that you had to use third-party software for this, which was really impractical because there's a lot of
Yeah.
issues like loading it and stuff. But let me new share this because I think it's a little bit unclear how to use it maybe the first time. So
Yeah, we did it in class and I was like, what?
okay, so you generally don't touch this first line.
Okay.
You just touch this. So in our case, it's 0. And that didn't like that. Okay, so let me try. It didn't like that either. Okay, let's try a different one here. So this one says dy dx equals 1. That's what this notation is here. So every ordered pair has a slope of 1. Like wherever you were to like pick a point, the slope is always 1. Do you kind of see that these lines all have a slope of 1, up 1, over 1? Okay. What is the antiderivative of 1?
1x.
Yes. Okay. Do you see how these lines are, this line that was just graphed, it has the same slope as these slope fields, but I can move it around. Okay. And so like if I go +1, it's on a different curve,
Right.
or lines. And I go down 1, it's the same thing. Okay. And that moves around because there's what's called a family of curves here.
Okay.
Right now, and let's do something a little more sophisticated. Let's say it's x. Okay. X means that the slope dy dx is the slope. The slope is whatever the x value is. So what is the x value along the y-axis? X is always 0.
0, yeah.
X is always 0. So you see how these lines have a slope of 0, the red, the black, orange, whatever color, purple, they all have a slope of 0. Now, if I go just to the right here, the x value is 1. So these all have a slope of 1. But if I go further, these have an x value of 2, so it's getting steeper.
Okay.
So these lines get steeper because their x value increasing. Go ahead.
Why is the slope like changing though as you're moving, right? Like
because the slope depends on only x. Whatever the x, like pick an ordered pair here. So let's say you're at the ordered pair 4, 5. Okay, what is the x value there?
5.
4.
Oh, 4. Yeah.
That's the slope. That's the slope there. Because dy dx equals the x value, 4.
Oh, I see. Okay.
So if we go to the ordered pair -4, 5, it's going to have a slope that's
-4.
-4. Okay. Now, what is the antiderivative of x? X squared over 2. So do you see how if you were to kind of connect some of these tangent lines that they would?
Yeah, go through it.
Yeah. So you might be asked to draw a curve or two, and it actually can move up or down depending on that.
Okay.
Okay, so where this gets way more complicated, and probably what you care about, is when you get a slope field of something that is not straightforward.
Yeah.
Okay, because so this says whatever the y value is, and whatever the x value is of the point, the slope is the ratio of those. So let's say we're at the ordered pair 5, 5, right over here on the right. The slope should be 5 over 5, the y over the x. So 5 over 5 is 1. That's why it's here. Now, as soon as x gets to be smaller than y, like let's say we're here at 2, 5, the slope here is going to be the y over x value, which is 5 over 2.
So like when you're starting to draw this, like where is the first place that you start? Like
Well,
when you're not doing it on Desmos?
Are you going to be asked to do these by hand?
I don't know.
Yeah, so that's an important question.
Well, we did some on a worksheet by hand.
Okay.
So probably.
Right. So that's the hard thing here is to do these by hand. So let's try a few of these. Let me go back. But the core thing that has to be clear is like do you understand that this means it's the slope? So
Yeah.
let's graph, let's do one here for dy dx equals x over y. So you have a graph like this. Okay. So you go to an ordered pair like 1, 1. 1 over 1 is 1.
1. Yeah.
Okay. Now you either move up or right. You have to move like in one direction. So if I go up here, this is 2, 1, 2. So is it steeper or is it
Wait, if you go where?
right here? This is 1 comma
The
2.
same.
It's not, because it's now 1 over 2. See at this ordered
But doesn't
pair?
it only depend on the x?
Nope, it now depends on x and y.
Oh,
The slope is x divided by y. That's what this says.
so, but I don't get how that would make it steeper.
Well, or not as
Yeah,
steep.
I don't.
Well, what's the x value at this point? It's 1,
1.
and the y value is 2, so the slope is 1/2. So it's not as, it's because I'm using this equation over here. This equation,
steep. Okay.
yeah, less steep, whatever that word is. And then here it's 1, 3. So it's even less steep, right? So eventually these just become, horizontal lines. Now let's go to this point right here on the right. This is 2, 1. So 2, 1, this point right here, 2, 1. That means the slope is 2 over 1. So it's steeper than this. So it's like that. And then the next point here is like 3, 1. So it's even steeper. And then these eventually become like that. So you can't draw that many because we're not that good at drawing this, but you're supposed to show that it's getting steeper and flatter going this way.
Okay.
Now what happens at this point, 2, 2? At this point right here, 2, 2. So x is equal to y, so notice all these points along here are
1, the same.
yes. And then you got to fill in the rest of it. Like if you go this way, it's a little flat. So it's like,
Oh, weird. Okay.
Yeah,
Like I kind of get it, but it's still kind of
so it's very hard to draw these. Now it gets more difficult when you go over here, but like -1, 1, -1, -1.
Well,
still
then we
get
just
this
go the
behavior.
same. Okay, so basically what you should do is start with like the one that's the same, like,
Or something that's known, that's easy.
right. So the one like that's completely like flat,
Yeah.
not like flat, but like, you know what I mean?
Yes, something like that. But then what's going on up here? Well, at -1, 1, it's going this way. So it's kind of like you said, you got to get like some of it going and then fill in the rest.
Right.
And that's why I don't know how many you're going to be asked to do. It's like going out more than like 3 and 3 in each direction gets, very hard to make it clear what the differences are in the slopes. But yeah, you'll probably ask to do this by hand, but I would confirm that. I would say, hey, are we gonna have to draw a slope field by hand?
Okay. Maybe it'll be like one of the multiple choice ones too.
Right. Which of the slope fields is correct?
Right. We had some of those on Desmos, or not Desmos, Math Excel, like those.
Yeah. Now another thing they could have, so like what I was trying to, let's go back to one that I think is a little bit easier to draw here. And then here's the kind of question I would expect you to see. Let's say dy dx equals just x. So there's just an x. Okay, so the slope at like 1 is whatever the x value is. So this a little steeper kind of thing, a little less steep kind of thing, something like that, right?
Okay.
And then same thing over here. These are, it's just the x value. So that's negative. I'm sorry, that they actually get a little steeper going that way, and then a little steeper like that, and then kind of looks like that. And so if I were to get enough of these drawn, you could actually draw in a solution to the slope field, because we know that the solution is 1/2 x squared.
Okay.
And the reason that might be valuable is because there's actually another way to do this, and it works better on pencil and paper. But if you were to draw the family of curves here, and then you were to take an eraser, which I don't know if this will allow me to do it, but let me try this. If you were to just like, didn't do that. Okay, I was trying to cut these, like imagine your pencil upside down. Yeah, like you would just cut these out, but
Okay.
Otherwise you're just drawing the lines at each point.
Right. Okay.
And they're always lines. I mean, they're just little segments.
I see. Okay.
So slope fields are very interesting, very useful. But like your instructor says in this problem, what is the slope at x equals -2, 0, 1, and 2? I think you might have to make a table for these.
So do you just like look for the y value at that point? Is that
Well, so we can do another one here. Let's do another one here. So let's say y dy dt equals cosine t. We know that the antiderivative of this, or we know that y is sine t
fine? Yeah.
plus c, right? So if I were to come over here and graph the slope fields for cosine, I better get a curve that looks like sine,
Fine.
right? Which we know sine looks like that. So you're not gonna get that. You're gonna get a horizontal, and then you're gonna get like a something. Oops, get that over. You're gonna get one here. You're gonna get kind of this, and then it's gonna look the same when you go up.
Okay.
So these are all, and you'll see, you'll start to see the curve that maps in there. And these come from evaluating cosine. So like cosine of 0, let's say we wanted at t of 0, cosine of 0 is 1. That's why this has this slope here. Cosine of pi over 2, okay, is 0. And that's why this one has a slope of 0 there along this point.
You have to fill in the lines for like all like
No, like you have to fill in the slopes, but then your instructor might ask you to fill in, draw a curve, draw a parent function. And since you know that it's sine, like you're supposed to be able to really like, oh yeah, it's one of those.
And then, but do you draw like all the lines around it too? Like
as many as they want. So
okay.
so there's another one here, right? And that's, then there's yet another one. So
Right. Okay.
I don't know how many you would have to graph, but we can
Okay.
So this one is kind of interesting, this that your instructor provided with the slope field. You may be asked to do something like this where you have to maybe not determine the solution, but say what the solutions are. So like here, the solutions are circles. Because each of one of these is a circle.
Right.
You might see a slope field where it looks like oscillating things. You'd want to notice that as well.
Okay.
I'm not sure if there's anything more to say on this topic other than to like give you really weird ones that
Yeah, this is fine. We can correct it later too. Like,
Okay,
another
yeah,
day.
okay. So we have a choice here. We can go on to 7.2, or we can just do some more practice with definite integrals, which actually it looks like 7.2 is more practice. Oh, it does move into use substitutions.
Yeah, it does.
Okay. We should do some more practice though, like,
Okay.
and one of the things that is kind of encoded in here is this fundamental theorem of calculus, which your instructor does. So you can just look at one more example here. All right, so kind of, so your instructor is kind of laying in these new problems here. So let me, if I tell you, no, let me use the right notation here. If I tell you f prime of x equals x, okay, and I then tell you later on, I tell you that f of, let's just do that. I tell you that f of 2 equals 1, and I want you to find f of 4. There's two kind of ways of doing this problem. So the first way is to determine the antiderivative of this.
Okay.
So the antiderivative of this is 1/2 x squared plus c.
Yes.
This is an initial condition right here. So this initial condition allows us to find c. So 1 equals 1/2 2 squared plus c.
So then it's 1 equals half of 4, so 2 plus c, so -1.
Yeah, so c equals -1.
So then it's 1/2 x squared minus 1.
Yes, so f of x equals 1/2 x squared minus 1. So now f of 4 you can get by putting 4 into this equation. That's way number 1.
Okay, so 4 equals 1/2 4 squared minus 1. So then that's 4 squared is 16. 8 minus 1. 4 equal, or it's not 4.
So it's 8 minus 1. It looks like it's 7.
7. Yeah.
Okay, so that is way number 1, right?
Okay.
Way number 2, which I believe is what the instructor is trying to emphasize here, is that f of 4 equals f of 2 plus the integral from 2 to 4 f prime of x dx. So let's look at, we're going to do this, but let's look at where the numbers came from. We want to find f of 4, that goes over here. I gave you f of 2, that goes here. And then it's 2 to 4 because it's where you left off until where you're going.
All right. So
now let's just substitute. This
7
is 1
equals.
No, we don't. This is a completely separate problem. Like we're going to get this answer. This is the integral from 2 to 4 x dx.
2 to 4. Wait, how do you know it's x?
Because it's given.
Okay.
So there are two ways to do this problem. Like the way on the right, I don't know which way was shown in class, actually, because it looks like these are all calculator problems. That's weird anyway. But this is the second way, is you to find f of 4, use the given value plus 2 to 4 to find the rest of it.
So then you just do antiderivatives. So like x
Yes.
squared over 2 at 4 and 2.
Right. And this 1 plus comes at the end.
Okay. So then it's 4 squared over 2 minus 2 squared over 2, right?
Yes.
16 over 2 minus 4 over 2. So that's 8 minus 2. So then that's 6. 1. So 7. Yeah.
right? Do you see how these are the same?
Yeah.
They're always the same. But like, this is where I don't know if this is clear or not, but that like there are two approaches here. The
No, that
first
makes
one is
sense. Yeah.
and this second part is using the fundamental theorem of calculus part, I don't know, part something.
Okay.
So let's do another one of these on the left. So let's say I tell you that f of 0 equals 3, and I have to give you f of x. Sorry, let me give you f of x. F of x equals e to the x, and I tell you that f of 0 equals 3, and I want f of 2.
Okay.
So f of 2, according to the way I think your instructor wants you to do this, is, let me write down here, is f of 0, because that's what's given, plus the integral from whatever this value is to this value, 0 to 2, f prime of x dx.
So you would have to write this by yourself.
Yes, you'd be given, you're given this, and then you have to do this next part.
Okay. So then you just do, so f of 0 is 3
Plus
plus
the integral 0 to
0
2 e to
to
the x dx.
x. Okay. So then that's e to the x, so that'll be 2 0, e to the 2 minus e to the 0, so minus 1. And then that's all plus 3. So it's 3 or 2 plus
E squared.
yeah, e squared.
Yes. Okay, so let's try another one here. See if you can set this one up. Okay. So let's say I tell you that f prime of x equals cosine x.
Okay.
I tell you that f of 0 equals 2 pi, and I want f of pi over 2.
All right, so it's f of pi over 2 equals f of 0 plus 0 to pi over 2
Yes.
cosine, wait, no, f of x.
You can just throw in, you can say it's cosine x dx. You don't have to keep like writing f prime of x.
Gotcha. Okay. So then it's 2 pi plus the antiderivative. So negative, is it negative sign?
It's just sine, because the derivative of sine is cosine.
Sine. Okay. Sine x at 5/2 and 0. And then that's whatever that is. Sine of pi over 2 is 1.
Yes, sine of pi over 2 is 1.
So pi 2. Oh, then that sine of 0 is also 1. No,
sine of 0 is 0.
0. So it's 2 pi plus 1. 2 pi.
Yes. Yes, very good. Okay, I think we got through everything for 7-1 today. And I guess we're meeting again tomorrow. So I will see you then. Thanks so much for scheduling. I'll see you next time.
Thank you. Bye.
Okay, bye now.